Unmute. There we go. Start the video. So we have a talking head of an old guy talking about random stuff. I'm sorry about that. But as far as back to our topic, there's something called the, 2 years these things have been sitting on the counter. It's bound to happen. It's called the Berkeley packet filter. Okay. This is actually in the kernel that you can turn on. This is low assembler stuff. Now what I want to do is kind of tell you a story of how assembler applies to you. Okay. The extended part is what is actually in the kernel. And this compiles, you can write code in C and compile it to a virtual machine. Now, virtual machine is defined in multiple terms. Okay. Virtual machine means 2 or 3 definitions. Welcome to the world of operator overloading in the world of computer science. A virtual machine is a virtual machine, but it's not, kind of, sort of, maybe not. Let me give you a, for instance, how many have done Python? Okay, or Perl, or Scratch, or something like that. And even Java to some extent. Okay. BIOS on BIOS on a high-end IBM machine, I would say hands down, yeah, because it actually builds the kernel as the machine boots based on the hardware that's in there, and it pulls what it needs and actually downloads the code that it needs to build a live kernel as the machine runs. But on a Intel Dell box in front of you, it's a firmware chip that has a bunch of code in it that the hardware says, oh, I'm brain dead. I need some more brains. Where do I go to get them? Do I go out the network card? Do I go to the disk drive? But in a way, you could argue yes, just like a virtual machine in your printer, because I can send code to a printer and make it print. I can also yes, yes, I'll agree with you there. And on your phone, you have the ability to sandbox out certain things. Okay. Now, virtual machine, as I've demoed it on this box here, means running another operating system on my hardware. That's definition 1. Okay. And let me go down here to my BIOS, my DOS prompt, and dir. You will see I have 2 files here. And this is exactly why you need assembler. These are both batch files. Remember I said, how do you write a batch file? Anybody remember? And what did you all say? I don't know. Right? It's just something else in your, do you really need to know batch files? Not really, but you should learn PowerShell. That's the up and coming tool. And Bash, you can actually write, you can put PowerShell on a Linux box now, and you can actually write controlling code for it. My view with the tools from Microsoft is you always wait, because their tools almost always have security implications, almost always. Okay, so I created a batch file here, and what happened with this, let me do screen share and just leave it on screen share so they don't have to look at my ugly face. All right, so it's now screen sharing. Here it is. Now, if I run SpiceCon here, notice that it's a little bigger. If I type in Spice, why does it expand that way? That's so irritating. there it is. And that will actually work, and will get connected, but it puts my password in clear text. It's so silly, but it's not meant to be super secure anyway. It's just a way to remotely manage. It's using the SPICE protocol to actually get to my virtual machine in my back office. Okay, it's working. So that one worked. Now, if I type in this other one, SPICE Con, what? Now let's look at them. Now I can't type the word type. Type the word type, SPICE. Yeah, you're on the right track. Yeah, I'm going to show you why hex is important to you. And I said, oh, this is a perfect demo. That's one of them. And the other one is client. What's the difference? Now, if you got, the eyes of an eagle, literally, especially for you in the back room, you'll see single quote here, single quote, double quote, double quote. That's the only real technical difference. But according to Batch, that doesn't mean a darn thing. You can use either quotes as long as they're the same, and I could change it, and it will work or not work. So I go, like, why doesn't that work? It's so dang simple. How do I find the problem? Oh, I think I have to use a different tool. Let's see. Maybe I could do that. Is GVim part of this? Let's see if this works. Ah, perfect. Okay. Now I realize it's a little small. I got both of them, but there's tools here, and I can convert to hex. What's a 0D, 0A? Remember that ASCII chart I handed out? Any clues? It's the carriage return line feed at the end of a file. So my file starts with a carriage return line feed. That's fine. Batch lets me do that. Okay. So that one looks fine. There's nothing wrong there. Okay. Now, if I go to the next one and convert to hex, what's my first two characters? FFFE. Don't ask me how they got there, but that's why that script doesn't work. This is why you need assembler to debug at a level like this. You kind of need to know ones and zeros. And this is a real case example. This kind of thing saved me 1,000 hours of fixes and gave me a raise, more than one. Case in point, Foster Farms, they'd print. In those days, they had big line printers. They'd print, 200, 300, 500 lines a minute, 1,200 lines a minute. Those things sounded like a tank. And there was this one route that actually they'd print, and it would go to this super high-end IBM printer that printed, I think, 1,200 plus lines per minute. So it was just kicking out page after page, because the invoices had to be in hard copy to go with the drivers. So the people that received the shipment could actually look at the invoice and sign it. Okay, so they verified the shipment. Okay, now that's all done electronically, but in those days it was all hard copy. And they were printing this route up in Kelso, Washington, and they print, and all of a sudden, all the print got smushed into a little corner it put, for some reason, the printer was going into an advanced mode and it was printing all the characters in one little square. I mean, it was a mess. And I said, well, we can't do this. And I said, okay. So I was working with the guy up there and I said, tell me the name of the client list. Let me see the report. And then is it always the same order of clients? And he says, I don't know. Let me go check. Yes, it was always the same order of shipments, the same customer name, address, because it was alphabetical. And it would get to a certain client number. And then the very next client number is where it went squish. I went, found the problem. It's related to this customer number. Now, where is the problem? This is a true story. You can scar on my back to prove it. Okay. The data entry folks had embedded a Control F1 into the extended information customer form. So there's the customer form and there's an extended information. They accidentally fat fingered a Control F1, and that Control F1 made the printer go into compressed mode. I fixed it. You try to explain that to management, you get blank stares, kind of like what I see here. Okay, this is low level. This is real stuff. This is the stuff that can make or break your, well, I won't say that. This is the stuff that gives you raises. So you don't have to do the, the boring stuff, because most of you will start off, if you're going to be a programmer, software, you're going to be fixing other people's crap. And one thing I will tell you is that's no fun. You want to get out of that as fast as you can. Okay. So do what, learn the tools you need to get out of that, because fixing other people's crappy code is no fun. Okay. It's got a pretty high burnout rate. Okay. So we have a true story. One I just demoed, and one I used from my history. Okay. All right. More information than you ever wanted to know. But as we go through, we are actually going to have where we're going to, you'll do readings. There's reading questions, and then we're actually going to have some labs, and we're going to have some really basic labs here in Assembler, and how to write in Assembler for the virtual machine that's actually on this computer. Okay, and this is a MIPS. It's kind of like a variation of ARM, but it's only an 8-bit register. Okay, so this is not real world stuff, but it's because if I gave you here, let's do assembler on the Raspberry Pi using 64-bit. Oh, by the way, we have to now learn about offsets and all this other stuff. Your brain's going to melt. Okay, but you can do all that on the Raspberry Pi, which is really pretty cool. So we'll be doing some of this. So this is kind of let you know where it's going. And then I made all these other ones optional. So all you have to do is skim through them if you want. And you don't have to do them. But the labs, I will unhide them as we go. This just got turned on, I think, over the weekend. So I didn't really have much time to vet much of this stuff. Okay. But where we're going with the definition of virtual machines, EBF. Now, I want you all to do a search on Google, or you can use Bing, you can use DuckDuckGo, I don't care. But open your browser in front of you and search on EPF for network issues or debugging, network and debugging. Okay, debug. Okay. You may not find a lot, but just keep searching, drill down. Let's see if I can find a link too. And let's do this, because I found one yesterday. They go, oh man, I got to show this to the class because this is the other definition of the virtual machine that we're talking about. Okay. Oh, look at there, kernel version. Oh yeah, this is where I found it. This guy. This is a really good article. Okay. He's explaining what this is. Now, the definition of EBF here for the virtual machine is as follows. It's in the category of Python. Okay. So when you run your Python code, do you have to do anything special other than click button and run it? It just works, doesn't it? Well, what's it doing? Magic. What Python is doing is creating a virtual machine that runs the assembler that is interpreted on your native machine. That virtual machine only lives for the duration of your Python code. This is how Scratch works. This is how Perl works. This is how Bash works. This is how Smalltalk works. This is how Lisp works. The concept of a virtual machine a long time ago simply meant you ran code and it built a custom virtual machine and then it went away. It was in RAM. Okay, that's the second definition of virtual machine. That's the definition that's used by this BPF. This tool lets you investigate things like who's doing what on the network. Somebody's logged in with SSH. What are they doing? Oh, they're trying to obfuscate using a command line. You can actually find exactly what they're doing. So do you think Big Brother's watching? Oh yeah, duh. All these AI agents, a lot of this stuff is automated, but this is explaining what's going on. So when you write C source code with the library for EBF, it actually compiles the assembler that runs on this stack, shall we call it, so you can do deep packet inspection on each and every TCP/IP socket or every piece of data that goes across the wire at a very high speed. Now, this is a money ticket because this is deep security. Okay. If you read fiction, and I like to read different kinds of books, and I just finished one with Jack Carr. He's the guy that goes around killing people. It's a blood and guts type of novel. But the writer is actually a former Navy SEAL. So I learned a lot about weapons and guns and stuff. I don't know anything about them. I've never, I shot a gun in Boy Scouts. I might be able to hit the broadside of a barn, but that's about it. I have no interest in guns, but I want to learn about them because I know people that are really into it. And it's kind of nice to know a little bit so you don't sound like a blooming idiot, kind of like following a sports page. Okay, preppers and all that stuff. I said, you're working too hard. All you need is a knife and a lighter. You work on the knowledge side of being a prepper, not all the gathering of the junk. What do you do with all that junk? Anyway, but what this allows you to do is do some really deep understanding of what's going on in security. The Jack Carr novel I just mentioned has a character called Alice. She's an AI framework. And they talk about the levels of internet fiction, of course. There's the level you and I live in. And then there's 6, 7 layers above that you have to hack your way into privileges. Okay. Now that's sort of true. Yeah, you have to kind of prove your chops to be able to get onto the dark web, to be able to find and do things. So you have to have a deep understanding of networking and low-level stuff to be able to get into that club. Well, that's what they're trying to train people in security to do, is to learn how to do that stuff. It's not easy. Okay. It's very complex. Okay. But that's the second definition of a VM. So when you're reading terminology about virtual machines, there's 2 definitions. This happens frequently in any discipline, not just computer science, where you have a term that means multiple things depending on context. This is also the fundamental thing that's also gave me another raise. No, this actually gave me a huge raise, is business rules. I guess I could tell one more story. The top sheet report. I was asked to go through the entire company to find a top sheet report because the guy on top wanted a top sheet report. And did I say that already on this class? Maybe not. I didn't know what the top sheet report was, and he wanted me to write it. I said, well, what's on it? He said, I don't know. I want it. I said, do you have an old copy? No. Okay. So it was really hard to write a report that he couldn't tell me what was on it. Okay. Yeah. Brainwaves don't work that well, you know? So I walked around the company, MBWA, management by wandering around, and I started asking people who knew about the top sheet report. Talked to this old gray hair lady. Oh, that's our material transactions report with the last page, which was the summary page, put on top, as in the top sheet report. I went, oh, I can fix that. That was easy to fix. And it made the boss really, really happy, because then he could click a button and get his report, his 1-page report. And then I had it automatically go from the computer into a text file, and it emailed him, and it popped up in an Excel. He thought I was a genius. It was great. He was very happy with that. But again, what do you mean when you say invoice register? You immediately have an idea of what an invoice register is. What if your accounts payable and your accounts receivable? Does it mean something different? It certainly does. Okay. Okay. Payable is where you send money out. Receivables is where you get money in. So the invoice register, they're looking at different invoices based on their job function, but they're using the same term. So when you go to work in business, ask people what they mean when they say some buzzword. What does that mean exactly? Can you show me? And you'll say, okay. Because there were many reports I worked on, and they said, what's this column for? I don't know. If you don't use it, do you want me to take it out? No, it needs to stay there. Really? You're looking at bogus information and you want it to stay there? Okay, whatever. No worries. No skin off my teeth. Makes it easy to adapt. Okay. So that's a little bit of a side jaunt of where we're getting into in this world of Assembler. Yeah, talking to Xavier this morning, I realized that I probably need to fill some gaps in your world or in your knowledge base. Compiled versus interpreted. How many could pass a quiz on what that really means right now on a blank piece of paper? Couple of you, yeah, because you got some experience in this stuff. Xavier would, because I just explained it this morning. That's what I thought. Okay. I'm not dissing you. Okay. Don't take it that way. What I'm going to do is is explain it, because as an instructor, I realize skill sets change based on the students that come to school. When I started in 2005, people knew how to install an operating system because they've done it 10 times. How many of you have actually installed a new operating system on an old computer? 5 of you, 6 of you, maybe. See, that's not bad. It's just that when you buy something now, like a Chromebook, it just works. You buy a notebook with Windows, it just works. You don't install anything. It just works. Okay. Like, you install the Android on your phone? No. In the early days of cell phone, you had to do that. I mean, the brick ones that were this big. Okay. We're going to talk about compiled and interpreted, and I'm going to explain what this means. Okay. Because this compile cycle is something you will need in assembler. Okay. Now let's start by going into, let me make it bigger. And now for you folks in the back room, let's see here. Can you see that kind of vaguely? Okay. Okay. Let's do LS here. Let's go into bin here. And I'm going to simply bring up Days Alive. This is a shell script. And I have some flags setting it for debug and verbose. And basically all it's doing is it's finding out somebody's birthday, and it finds out how many years they're alive using modulo and integer division, which you've worked on. Well, maybe in previous classes you have. The C and the Python classes are working on that. And so it's giving me a divisor, and then notice it gives me alive. That's how many seconds are in a year. That's the whole number. And then how many seconds do I have left over? That's the modulo. So if I've been alive 5.5 years, the 0.5 years in seconds is what's the next number. And then I divide that by days, whole days, how many seconds in a day, and then do the same thing. Okay. Been alive for years, days, and seconds. Okay. That's it. That's all this script does. But to run this script, all I do is the same thing as I do in Python. I type in bash and then the name of the script, and it runs. So I'll put in the birthday of Linux, or excuse me, Unix, 1970. And yes, I'm a little older than that. Okay. So Unix has been around for 52 years, 274 days, and that many seconds. Okay. That is interpreted. Bash takes the commands and allocates them to a chunk of RAM. It compiles them internally and then runs the code, and then the code exits, and that's it. Python does the same thing. So if I create a simple Python script here, let's do let's just do a simple loop. We'll call it loop1.py. Okay. How many remember Python? All right, quiz. Write a for loop that counts to 10 in the programming language of your choice. How many are drawing a blank? Because you know what's happening. Oh, I Googled that. Google's great. I get it. But it's okay to memorize a few things. Like the phone number to your parents, okay? Or the top 5 that you use on your cell phone, okay? It's okay to memorize a few phone numbers, okay? Besides 911, okay? So let's create a Python script. Now I'm going to use the convention user bin env. Problem is typing and talking doesn't always mix well. I want to go to Python 3 because this is an older box and I called this loop 2 or 1. I'll say whatever, I'll rename it. So we say for x in range 10, semicolon, and then tab, say print new, comma, and then x. And then, yeah, that's good enough. Okay. So there it is. And then I like using some sort of tag at the end of the file. You know, when I bring up my editor, the VI editor, these squirrely brackets, those are invisible. That's just telling you there's a blank line there. Oh, this thing. It's a light. I should have turned it on. Smile. You're on candid camera. That also shows you how old I am. You'll have to look up candid camera and find out when it was actually on television. Okay. So there it is. So it's called loop 1. So I named it. So let's fix it. Loop 1, loop 2, let's make them the same. This is a convention that I've used since I started coding back in the 80s, is that I make the second line the name of the file, because when you're dealing with code, you're oftentimes dealing with many, many files. If this goes to this goes to connect, and then if you don't know what you're working on, you fix it. What did I just fix? Where is it? Which one of those 100 files did I just edit? It's a way to save you some headaches. Okay. All right. So here we go. So I type in Python 3 and then do my loop. And everybody knows what's going to happen, right? Hello. And it's going to print 1 through 10, or is it 0 through 9? 0 through 9. Okay. So that's a good technique when you start coding, is before you run it, try to think what it's going to do. Okay. And I will tell you this, if you code long enough in a specific in a specific tool like C++ or Perl, I got good enough with Perl, I could do this. I could look at a printout and say, that's not going to run. I couldn't exactly tell you why, but you get an intuitive sense when you stare at code all day, okay? And you know if it's going to work or not, okay? Like when I do Bash, I almost always make a mistake because it's so obscure. But with Python, I can think in Python without too much difficulty, okay? For me, it's a great tool to do a lot of things in, where you code in it and then forget it for 6 months and then go back to it. You can pick up where you left off. Also, if you're into security, Python, big deal, okay? So there is no compile cycle there. It just worked. Well, Python creates a virtual machine that lets you see what's inside of it. Do a quick search on Python virtual machine and see what you come up with. Let's see what we find. There we go. This actually talks about how it's actually working. This is your world. You love the browser, right? Everybody loves JavaScript. Yep. What's happening is the interpreter creates a VM that lets you do inspection at a low level on system calls. So you can find out how fast or slow your Python is running. And you can actually change it from a for loop to map reduce and get a order of magnitude faster if the loop is big. How do you find that out? Well, you got to drop down into the virtual machine and read the assembler, the debugger. When somebody says you know how to code, or you say you know how to code, and then you get a question in an interview, what debugger you use? And they say, oh, I use print statements. That works. But that means you are a junior level programmer. You're not senior. Knowing the debugger, the big fish in the pond is GDB. It's a monster tool. And we will learn how to use it at a very, very basic level in this class, because it is that important. You can use it across the discipline. You can use it in networking. You can use it in kernel development. You can use it in stack space development. You can use it in database, you name it. It's important to know, okay? So this is all about it, okay? All right, so it actually lets you disassemble the code that's running in this space. You can actually look at it in assembler. Now, why is this important and why do I care? What does Python run on? Mac, Linux, Raspberry Pi, Windows, blah, 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 blah. If I write a Python script and you've got Python installed on your computer, can you run it? Pretty much. It's cross-platform because of this thing. The virtual machine is specific to the hardware on your Python install. So when you write your Python code, it gets translated into this generic assembler that runs on anything, even a satellite, if you want to get down to it, okay? Now, I realize some of this is a little bit on the dry side, and you can't see how it really relates to you wanting to get a job working in the world of JavaScript. I just want to do web pages. That's fine. But JavaScript, when you write an error, all you get is a blank page. It doesn't tell you what went wrong. You have no choice. You have to use the debugger. Okay. Now, where is this going on? Now, this is what I'm going to talk about next in this pile of buzzword blizzard, is how it applies to you. Okay, is that this is kind of a dry topic. I get it, but you use it every day, and you just like use your car or not every day. There's a lot that goes on in the car that you don't understand. Well, that's fine if everything works, but when it doesn't, that's why you pay people. In computer science, you get paid to solve puzzles. And I've been doing it for over 40 years and it's still fun. And there is a rush that you get. You've been working on this mind-crushing problem, soul-crushing even, and you can't figure it out. Go for a walk, still can't figure it out. You sleep on it. About the third night, you wake up in the middle of the night. Ah! Try it. It works. You get this massive, yes. That doesn't go away. Okay. But it doesn't happen very often either. So you have to get used to frustration in this business because it's not going to work, guaranteed, the first time. If it does, stand back and be amazed, because it's a rarity. Okay. So this compiler, the virtual machine, and the stack space that we're going here, I want to talk about this thing that you use every day. Okay. You use the web browser, right? Yeah. And these fancy pages load up. Use JavaScript, right? Cool. How many have heard of the DOM? Document Object Model. And if you want to learn about JavaScript and you are going to code in JavaScript for on the web, I recommend anything by Douglas Crockford. He wrote, and there's some video series out. It's not that long. It's maybe about an hour and a half. It says the good parts, the bad parts. JavaScript, good parts, bad parts. And he explains why it sucks in the computer science realm as a programming language. But then he also explains why it's so good. He explains the low-level technical guts of why JavaScript is what it is. DOM is one of those things that he says sucks big time. Okay, what is it? The document object model is a way to put your virtual machine that we just talked about in the web, on the browser, so you can do stuff. Okay, when you write JavaScript code, you are going to manipulate the DOM. Okay, and you say, oh, I'm going to use all the tools that abstract it away. Yeah, right. That's not going to happen right away. Okay. What we're also talking about, the same piece of this puzzle, is something in the world of Windows and the world of Linux and the world of Mac OS, Chrome OS, is the environment. Okay. This is all related to this virtual machine idea where we play with assembler. Okay. Now, trying to put together these pieces that make this whole world, this ecosystem. I'm giving you a lot of glossary and a lot of, oh, look at this. This is cool. But what's it mean to me? There's no relevance. I get that. It will be. And then I'm going to say, do you remember? Anybody? No. I'm going to ask you to go back and reread something. Okay. That's going to happen because you're going to learn and forget so much in this business. I've forgotten and learned more than I can. Anyway, the environment is this thing. Let's do a quick demo. I'm going to say X equals high. Where'd that go? It's in a chunk of RAM that is allocated to me when I log into the system. And I've set a variable. If I open another window, which I will go do now, open another terminal window. Click. Where'd it go? Bingo. How many have set a path statement in Windows? I'm one or two people. That's where, see, that hand used to go, everybody used to say, yeah, I've done that. Well, now you don't because it's all automatic. Well, what's a path statement? Path statement tells you where to go find an executable. When I run my hello world, where is it? Okay. So we're still talking about the interpreter and the virtual machine. And now we're getting into this environment and DOM. Basically, in your web browser, the DOM is your environment. So you set variables, retrieve variables in the DOM, in the memory space. Lo and behold. Now, how many have heard of Node.js? Yeah, most of you, there's a lot of jobs in Node right now. And what is Node? Well, it took this V8 virtual machine that runs JavaScript in your browser and put it on the server. So now you can run your web page on a server and it runs really, really fast. Okay. That's what Node.js does. That is claim to fame. And the guy that put together Node.js says, I did a lot of things wrong. I'm a physicist, not a computer scientist. So he's rewriting Node and he's calling it Deno, which is kind of a anagram of Node. Okay. Environment. It's unique to you while you're on a web page on a DOM. Okay. Now, one thing about JavaScript, I want to actually, you should write this one down, is that how did Brendan Eich get JavaScript to market in 6 weeks? How did he do that? He did not write it from scratch. What he did is he took something called Scheme. It's a programming language, interpreted, creates the virtual machine, runs, very elegant, lots of error correcting, deals with recursion, stack space, very elegant language. He stripped out the Scheme syntax, which was lots of parentheses, and made it look like Java. Hence, he called it JavaScript on purpose to confuse the market, to get people to adopt it when they didn't know the difference between Java and JavaScript. Now, you should all know that, okay? If you don't, I'll explain it, okay? JavaScript is interpreted. Java is compiled, but it's compiled to a virtual machine that runs on a platform, okay? So it's still compiled, okay? Environment, DOM. So if you really want to understand the guts of JavaScript, go look at Scheme. And there's a textbook. It's called SICP, Structure Interpretation. Yeah, I think it's that. Or is it SCIP? I don't remember. Structure and Interpretation of Computer Programs. Yeah. The original copy was used for literally decades at MIT to teach entry-level computer scientists. Okay, there's no way we could teach that today. It's Scheme. Scheme doesn't have a market. You can't get a job working in Scheme, but you can in JavaScript. So if you understand how Scheme works, you can understand JavaScript works. Okay, that's how he did it in 6 weeks. Now let's talk about the compile cycle. Okay, let's do this one. Let's do let's just do one really simple. How many have had either Java or C++? Okay, most of you are supposed to have had at least one semester or a year of programming. This is basically C++, and this is what you write in English, and or whatever language you want, and this is the stanza. Now, how do we make it work? Can I type in type in this and make it work? No, no, because I have to do something called compile. And again, I cheat. I'm going, oh. Let's see here. I think I actually have to go into where it is, Control C. All right, we'll do it this way. Let's cat the file. Yeah, and now let's right click. Now I can copy it. Middle. Okay, right click then, darn it. This is the compile. What it's doing is, do you see that in the back row? This is the actual compile. Is G++, hello, this is the English source code. And my output is to a run file called hello. And I'm using warning all, give me all warnings, and use the standard of 2011 for C++. Now, if you follow the standards, now this is really obscure stuff. You don't have to remember this, but if you follow the standards of C++, where it's going as a language, it's stealing the ideas from Rust. So you could make your future in C++ because Rust is kind of taking over in certain points, but C++ eventually will get that mindset back, and you'll be able to do the same thing in C++. There's a lot of C++ code out there, like a lot of COBOL. Okay, so now when I create this file and I run it, blip, if I made a syntax error, it gives me an error. I cannot compile it. What this is doing, G++ is taking English source code, compiling it to the architecture on which the machine it is, i.e. a Linux box, giving it a name, asking for warnings and using the standard. So now if I do my ls, there's the file. That's how big it is. And that's when it was created. Okay. So now if I run this file, I'll say max. Now, what is that file? Well, it's this. I use this. I'll use the hex dump. Okay. Hex dump, canonical, hello. That's what it is. It's object code. It's the result of your assembler. We are going to learn how to take C source code, compile it to assembler, and then take that assembler and link it and run it. Okay, that is a job skill. That is something you're going to need to know. I've got a book, Cracking the Coding Interview. It's about that thick. It gives you all these questions that come up in interviews, like at Facebook and Google. Those are tough questions. I could not pass a Google interview. Okay, too rusty. Okay, and old. Okay, so when you compile it, it converts it into this object code. Now, I have this object code. Okay, hello. I can take this and put it on your machine in front of you, and it's going to work because they're both the same hardware platform. Okay, this is why people say, oh, I cannot give you my source code, but I will give you the object code. Like NVIDIA and their libraries for Linux, you cannot get the source code, but you can get the binaries. This is a binary, and it's specific to this hardware. G++ also lets you compile this same exact program to an ARM chip. So I could actually use the Linux box to create a Raspberry Pi program. okay? Or maybe an older Mac, you know, on the PowerPC, okay? All right, so that's the difference between the compile cycle and interpret it. That's a big one, okay? You need to know that, because when you're working in a language, is it compiled or interpreted? Well, I'll do a quick demo here, and I'll go over to my Moab Xterm here and bring up. Now this might be a little hard to see in the back. Let's see if this makes it bigger. No, I didn't think so. All right, but anyway, I have this little demo I put together that I keep adding languages to it because I'm kind of like a language geek. I like to learn different programming languages. Yeah, I am a quirky dude. Stars. And what I've got here is a bunch of different programs that simply print a million stars to the screen. And I've got Lua and Ash and Bash and C and C++ and D, and I don't think Fortran works. Go. I've been playing with Go a little bit. Go's got some pretty slick stuff in it. The network stack in Go is pretty awesome. Okay, Julia, more Lua, NL is New Lisp, Perl, Python, Ruby, and Rust. Okay, but when you compile them, look how big Rust is. That's Rust is a compiled language. Look how big it is. I didn't put Java in there because I don't like Java. I never did. Okay, I avoided Java my whole career. Pardon? Yes, and what ends up happening is that there's no optimization in that. You can actually throw switches on the compiler to make it smaller and faster, and you get a big difference. But what I want to do is run my shell script that runs it all together. This one, stars times speed, and I know that it works on that machine in my office because that's where I've got it all set up. And what happens is that's a million lines or a million little stars in Bash, and it takes 4 seconds. Okay. And this is in Dash or Ash. It's a POSIX compliant shell. It's 1.8 seconds. And Go is 1.0. Now Go, you can run it 2 ways. You can run it interpreted or compiled. That's pretty slick. I like that idea in Go. Okay. PHP 0.8. Julia, well, that one's, I need to install Julia. Ruby is 1.8. Python is 0.2. So Guido retired. He's about my age, maybe a little younger, but Microsoft called him back and said, we'll give you a blank check. Do whatever you want with Python. And he says, okay, I guess I'll unretire. And he's working on the speed to make Python even faster. Okay. And Lua, how many know Lua? Gamers, yeah. Lua has got some cool stuff in it. And I happen to like the language. 0.1. Lua is small. And it's, you don't write an accounting system in Lua. That would kill you. Don't do that. Lua is a glue language to put pieces together. Let's say I want to put Rust and Go and C++ together and run something. Well, Lua would be an example of glue that allows you to run these things and, you know, maintain, you know, so it's more of an extension language than a development language, okay? And the mismatch there is because I've got 5.3 and 5.4. Anyway, Perl 0.08. That's pretty darn quick. Perl has been around a really long time, and a lot of smart people have been working on it for many years. Rust is 0.9. C++ is 0.09. See how fast that went? Well, C++ also knows that my computer has 64 cores, and it automatically compiles that optimization for that. Okay. And D is kind of a systems language that if C++ gets to be too gnarly, you use D. And D is a programming language used wider in Europe, but it's used in super high performance computing. I mean, let's model the nuclear bomb going off in 5 different places all at the same time. Okay, that's where you would put D. Okay, and C, not found. I've got a problem with that one. I got to fix that one. Okay, so it's showing you the relative speeds. Now, what will happen here is C is actually slow because the default is use 1 core. I got 64 or 63 are just sitting there idle doing nothing. Okay, so depending on your language, depending on how you compile, you can get some optimizations. And maybe by the end of the semester, we'll add a similar to this. Okay, and we're going to say, how do I print 1,000,000 stars with assembler? Okay, we'll add it to the list of things we're going to learn. Okay, so that's today's longish out and about thing. So I promise we are, I still need to go over 2 more things, file folder and FAT. I'll put that up here. And files. How many have put stuff on their computer and never found it again? It's happened to all of us. I was my wife's biggest hero because she lost her master's thesis. She was sending it to her professor, and professor made all the changes, and then she got it back, and she saved it, and couldn't find it. In Windows, you have this little view thing, hidden item. When you receive a file and your email, and you hit save, it saves it to disk, but it doesn't tell you where. And you search and you cannot find it because search will not look for hidden file unless you click hidden files, and then you can find it. Okay, so I found her master's thesis. It was in a system directory where the default file saves go when you hit save on an attachment. And I was her hero for about 15 minutes. And then I did something stupid and got in trouble again. So can't win. But nevertheless, that's that. Now, we're going to talk a little bit about this navigation thing. Okay. All of you know how to mouse around to find your stuff. Can you do it from here? You need to. This is what I would consider foundational computer science stuff. I need to write that. I'll put that in the link. I actually need to give that to all the classes. It's a course, it's free, and it's called the Missing CS class. And it's, 2 or 3 hours, maybe 5 hours. I don't remember how long it is, but it's all about this stuff. Maybe I'll just give you that link and let you go look at it your own. That way I won't have to ramble. But this is foundational stuff. Like if I go to desktop here, and if I say MD, make directory, call new stuff, and I do my dir, you can see my new stuff. Well, spelled funny. Okay. Now, if I go to my desktop, what am I going to see? Let me minimize all these windows so you can see what I'm getting at. Make sense? At the command line, I created a new folder. This is like, you know, we should all know this stuff, but it's one of the things we don't teach directly anymore because we just assume everybody knows it, which is not true. Okay. Okay. So now if I delete it, put it in my trash bin, is it really gone? Nope. Empty the trash bin. Is it gone? Nope. It's flagged as deleted. The first file in DOS, old school DOS, we'll use that as an example. It renames a file with the first character as a question mark. So if you know hex, you can find those files and change that question mark into something else and get the file back. Forensics, security. All right, I'll shut up. All right, we'll call that a day. Sorry for took a little longer to cover all those things.